Welcome to Dane Authentication for Network Clients Everywhere, otherwise known as DANCE. I'm Wes Redeker, one of the chairs. Joey, unfortunately, can't make it this time, and just so you know, she's done a ridiculous amount of work. She does more than I do. I let her push all the buttons because she's fairly new to chairing and has just taken it on with enthusiasm. So I miss her greatly, and she's awesome. Back in IETF 87, way back in Berlin, I walked by this infrastructure that was like in scaffolding right outside the IETF hotel room. And for those in the back that can't read it, the little yellow, banners around this construction says "Time to Dance." I thought it was like the weirdest thing I had ever seen, so I took a picture of it, and this is a picture of it. And I didn't even realize until 2 or 3 IETFs that for this one it had to go on a slide, right? And clearly, since back in IETF 87, I have been destined to chair this working group. It's sort of my takeaway for it. People love it. It was a horrible shot to take. There was no good angle to take it at, but I did the best I could. So the note well, you have heard about this many times this week. You're going to hear about it again because it's important. Make sure that you understand there are legal ramifications for participating, especially under your sponsor at IETFs, especially with respect to patents and disclosures and things like that. I'm not a lawyer, so that's my 10-second summary of something you should have your lawyers look at. There's a lot of information about the Note Well stuff. In particular, we have BCPs on the Internet Standards process and how it works, the working group process and how it works, the anti-harassment procedures, the code of conduct, the copyright and patents and participation, as well as our privacy policy. The code of conduct guidelines are specified in RFC 7154, and they're important, and it's treat everybody with respect. I think this group generally has done that because we dance and play along nicely with each other. Speak slowly and limit the use of slang. Don't disrupt ideas, that was horrible. Dispute ideas by using reasoned argument and not other type of slang. Use your best engineering judgment for the whole internet and then contribute to the work of the IETF. I'll remind you, I actually thought that there was a mask on this, but there isn't. The IETF does have a masking policy. We should all be wearing masks at all time and working in IETF controlled areas, which are venues like this. And it's one of the reasons that our COVID transmission rate is so low this IETF, and I hope to go home without COVID, and I hope you do too. This is the information for the dance working group. There is, the normal information. There's a purpose, our mailing list, how to subscribe to it. And then we have 3 working group documents. That top one, actually, there is a 00 draft, and because my mail server's down, I haven't been able to click on the stupid email link in order to approve it. But it's actually there, and it's in the queue waiting for me to click on it. So we have 3 actual official working group documents, the biggest one being the architecture document. This meeting is being recorded. I think everybody knows that at this point. It'll be live it'll be on YouTube later. When you participate, please do scan the QR code with your phone or click on the link either on your laptop or on your phone version of the agenda. It's important for a participation count. So even if you're not planning on speaking, please click on it. It's also where all the fun chatting is going, which I'm not watching because there's only one chair. So if anybody else notices stuff, please let me know. For today's agenda, we just went through the chair's introduction. That was most of it. Tim has agreed to take notes. I'm sure Tim would really, really love it if somebody else would watch the notes and type when he's not, because it's a tiring job. There's a note-taking link in the agenda as well. There isn't a discussion about the call for adoption results. You can ignore that because we've already adopted everything. The working group activity is still kind of comes in small spurts, but we're actually getting stuff done anyway. We'll have a short discussion about the current work items, about those 3 documents in particular. And then we have 2 interesting dance use cases. One, Jacques Latour is going to talk about one from Sierra, and Bob Moskowitz is going to talk about DRIP and how dance might help in those cases. But we will start with the architecture document actually did conclude in May, and actually has been since the last IETF. And so there was a 3-week call. It was clearly had good support, so we did adopt it. And as I said, the 00 is coming out shortly. This is all of the mail that's gone through. You can see it's actually ticked up a little bit in the last couple of months, so good job, everybody. Nice way to dance. But more is always better. This is still a fairly low volume working group, but I think a lot of it is there's not much contention in the documents. With that, I'm going to turn it over to, I think Shuman is going to lead the slides, right? And I will pull your slides up. You want to control them yourself? You can use your phone if you ask.
I am not set up to do that, so I'm just going to ask you to advance them.
You just click on the little button on your phone. It's actually quite easy.
Okay, good afternoon, folks. I'm going to give a quick update on the status of the Dane core protocol documents. Next slide, Wes. Which are the following. So the first one is the Dane protocol. That's the Dane TLS client authentication document. And the second one describes the TLS extension used by the protocol for signaling the use of this mechanism and optionally to convey the domain name of the client in situations where that's necessary. The the main example is if you're using raw public key authentication. So, so I think these protocols are largely done, or maybe even done at this point. But I did want to highlight one aspect of the protocol because it took a couple of implementers slightly by surprise when they found out that there are some differences in where the protocol, the new protocol elements are placed in TLS 1.2 versus 1.3. So next slide, please. So in 1.2, we really don't have any choice but to place them in the client hello and the server hello, where they are unencrypted. That's the only thing that can happen in that version of the protocol. And as you might expect, there was some pushback from security and privacy folks about that. So we addressed that in the TLS 1.3 version of the protocol. Next slide. By moving the extensions into the certificate request and the certificate message on the server and client side respectively, whereas if you know the protocol, those things are encrypted. One other thing you might have noticed is the ordering has changed. So in TLS 1.2, the client sent the extension first in its first flight, client hello, whereas in TLS 1.3, we have to send it from the server side first because that is required by the protocol. The client ID extension in the certificate message can't appear unless there's a corresponding advertisement of that extension in the certificate request message. And I see a couple of people are queuing up for comments, so maybe I'll just
take them now.
Yeah, might as well take them now.
Victor?
Sure. I attempted to address this topic actually at the end of the Utah session by asking where I might be able to define a new TLS extension, yet another one, that would ask the server to solicit a client certificate.
Yeah.
In this diagram, the server, statically solicits one, but there are various applications where that's not the case. And so even in TLS 1.3, we could define an extension with no privacy payload at all. It just says, please solicit my certificate. And that might address this issue. The only question is which working group does that go into, UTA, this one, or TLS? I don't know or care, but somebody should have an answer. Perhaps Paul will tell us where that goes.
Is there any reason it couldn't go into this one when we're already defining other things?
It could perhaps go into this one if there's no, territoriality where TLS will say, no, we want to define it. I don't know.
You can still send extensions unencrypted in client hello, right? So you could stick some...
Right, if it has no content other than just the number of the extension, I doubt anybody will find that to be a privacy issue unless somebody here has a thought about that.
Oh, I'm sure we can find some way that's a privacy issue.
Martin?
Martin Thompson, I'm sure we could find some way it's a privacy issue.
Yeah.
That wasn't what I got up here to say. I'm interested in the previous slide, if you can show that one.
Yeah.
I'm going to ask the standard question here, which is why support a defunct protocol?
Why support it at all? Is that what your question is?
Yeah.
Yeah, that's a good question. So I think one of the ways we addressed that the first security and privacy objection was by saying that the dance protocols is probably going to be greenfield applications. So maybe everything will roll out with TLS 1.3 and we don't have to care about TLS 1.2. I think there was some discussion where people made the case that there could be legacy applications that we may want to retrofit with this. I don't have a strong opinion about this, but others should speak up on that topic.
Yeah. So there's a couple of other things that I didn't see in the draft that probably do need some consideration here in relation to this privacy issue that you have.
Yeah.
Essentially what you have here is the TLS 1.2 client for some classes of servers that it talks to essentially just publishes to the world its identity and the other stuff.
It does, but I mean, in TLS 1.2, they're going to do it anyway. If you're using client certificate authentication, isn't the certificate?
And that was the next bit that I was going to get
Okay.
to, is that there are a number of ways in which you can avoid having that happen.
Mhm.
In TLS 1.2, you do have the option to do a renegotiation. Now that's kind of frowned on, poo-pooed and whatnot,
Yeah.
but it does give you confidentiality for the client authentication pieces. And that is a very common technique that's used for people who are doing client authentication, particularly in those contexts where it is potentially sensitive information.
Right.
The other one to consider here also regarding Victor's point is we have post-handshake authentication in TLS 1.3. We also have exported authenticators, which both give you an option to provide information about client identity outside of the context of the handshake. So you can have something at the application layer that says, I need this information, and then you can sort of bootstrap into any of that. I didn't see any discussion of any of these options in the draft. Now, it's possible that some of these you're just happy to ignore, but I think the renegotiation thing is kind of a big deal if you're going to be doing 1.2.
Okay, yeah, so doing it outside the handshake, I mean, this is general purpose, so it can be used by any applications without doing, additional, complications in the application. That was probably the rationale, but I guess we haven't really discussed that. So
Right.
we can have a discussion about that.
Victor, I will encourage people to keep things somewhat short. We only have an hour
Yes.
today.
Okay, a couple of comments. One, the kind of clients that have privacy concerns generally don't end up as being nodes in the DNS tree. This was the primary use case for this originally was MTA to MTA, SMTP, and obviously it's being extended to all kinds of other client scenarios, some of which may have privacy concerns, but the initial ones, in the UTA, right, there's a long discussion now in drafts where UTA says you must implement TLS 1.2 still. TLS 1.2 is not a dead protocol. If you read, many of the wonderful posts by Peter Gutmann, TLS 1.2 is here forever. So I don't think we can ignore TLS 1.2, and perhaps some of the industrial applications, if they need this, would stay on TLS 1.2 for a very long time. And as for negotiation, we now have, for various security reasons about CPU denial of service attacks and so on, many servers now turn off renegotiation as a matter of policy. It's now considered best practice to say no renegotiate. So there are all kinds of barriers to doing it the privacy way, and many scenarios in which the privacy is not a desirable or at least a required feature. And unclear whether the privacy clients would find themselves published in DNS with their TLSA records or whatever.
It does seem like there's fairly violent agreement that we do both 1.2 and 1.3, and you're willing to take that on, I assume, in the document.
Yeah, I mean, it's been taken on, right? So we can
Unless
continue.
somebody argues heavily that
So-
we shouldn't do 1.2, I think we've solidified.
Yeah,
that.
so to Victor's point, so I agree, for the SMTP transport client case, clearly there's probably no privacy issue, but I think there's a bunch of emerging data IoT use cases where probably it will become an issue, right? So we may have to deal with it. It's a general purpose protocol after all.
Bob?
Well, in the for what it is worth department, in the TLS extension that the FAA is doing with SCVP draft, they were specifically told to pull out 1.2. that this is only going to be done, this is only be done for 1.3. Now, of course, theirs is a greenfield situation. So there is that distinction. So you should undoubtedly should put in text in here as for the justification of including 1.2 is that this is not for greenfield use, and there is this large community which will take some decades to go away. So include text for why the 1.2. That's why I came to say it, not to vote against or for, but explain why.
Yeah, that's a good suggestion, Bob. Thank you.
All right, thank you. Nick?
Hi, can you hear me? Great.
You're good.
Okay, so I wanted to follow on one point that Martin Thompson raised, and it goes back to some of the assumptions made in this design, which is that the authentication happens within the TLS layer in the handshake and not after the fact. And I'm wondering, first of all, question one is that a hard requirement? Is that just where the design ended up naturally fitting? And if it's not a hard requirement, I would encourage you to look at exported authenticators, because it provides a unified way to exchange bits of authentication from client to server and back that is compatible with TLS 1.2 and 1.3 without TLS handshake changes. As you sort of raised at the microphone, there will be potentially some additional changes at the application layer to support this exchange, and that might be too difficult. But if we're talking about legacy systems right now, modifying old TLS 1.2 server implementations seems like it might be just as messy as having protocol-specific DIN-based authentication post-handshake with application messages and exported authenticators. We also have stronger guarantees of the security model there because it's based on TLS 1.3 exclusively, even though it works with 1.2.
Yeah. Yeah, thank you, Nick. So I don't think that this is just the way the protocol evolved. So I don't think anyone really looked at exported authenticators, but that's something we could look at. So, but I do agree that we were trying to make it so that we reduce the burden on application protocol. They can just plug into the TLS layer that has these features and then be done, right? So asking applications to do a lot more work, I don't know if that's going to work or not. I see Victor shaking his head. Okay.
All right, can we let him finish the presentation, Victor? And if you still have a, okay.
Okay, next slide. So, as I said, barring that discussion, I think the document is mostly done. There were a couple of comments. These are, I think, from months ago from Michael saying he found the introduction really weak. He wanted more references to use cases and architecture. So personally, I think that's what the other document is for, and I don't think we need to necessarily burden this document with more details about application architectures and use cases. I could be persuaded otherwise. But if that's the case, we're waiting for that other document to be completed. So the question I'll throw out to the working group is, if we think this is close to done, should we
Which other document? Are you referring to the architecture
the architecture document, yes. Push this ahead, or do we need to wait for that document to be fleshed out?
So the tricky thing will be the forward reference to a document that needs more work than this one, right?
Okay, and yes, Michael will fix the capitalization of IoT. I think I have one more slide. Okay, so I think I'm done. I said what's here. So I'll stop.
Okay, great. So I think it sounds like one of the documents is likely fairly well done, and the other one sounds like after today's discussion needs a bit more work before we consider going to last call. So one of the things to the working group is I really want to know, what other outstanding issues are there before we go to last call for the documents, because they have been not super actively edited lately because they're already fairly complete. So
yeah, I mean the only thing is, if we're going to go down the route of looking for how to do this outside the handshake with exported authenticators or not, right? So if folks are interested in exploring that, I'm game, but there are some downsides, right? So,
Victor?
Just in terms of being done, I do think we need to figure out whether the please solicit my certificate is sort of requirement for this one to be finished or not. If it doesn't go into this specification, it could be done specifically for SMTP through ESMTP keywords and some ugly hacks that are kind of at the wrong layer, but the client could issue an ESMTP command that says, please solicit my certificate before doing start TLS. I think that's the wrong thing to do at the wrong layer. So I think part of this protocol might be this one more extension that would go into it. If there's no major objections, we could add it. On the other hand, if there are serious objections, we should figure that out on the list, perhaps.
So the only objection that I can personally think of, from the chair's point of view is it going to be used, right? So
I think that's the only way I can get this protocol into SMTP without changing SMTP.
well, then there's a good use case.
Right.
okay, and then we'd also have to answer the question of in which venue should that work be done, right? Is it general purpose or does it apply only to the thing we're talking about here?
Sat down too early. It applies any time that servers selectively solicit client certificates.
Yeah.
And
so I remember I had this discussion with you. I think
right.
SMTP was the one arena where you encountered this issue, right? Are there others?
Anytime really that clients don't usually have certs, where it's not anticipated, and where there are interoperability concerns, because when you request certificates from clients, some of them will blow up and say, I don't have a certificate, game over. It's common with Java and some other systems.
Yeah, but if they're protocol compliant, they're not supposed to blow up, right?
Who knows? The implementations differ. So in fact, a server that isn't always requiring client certificates, but optionally, if a client presents one, might do something with it. Any application like that could benefit from the client saying, I'm happy to give you a certificate. Please ask me for it. SMTP is MTA to MTA SMTP is a good one. I only know about that one. Other people can speak to their use or non-use.
Okay, Ben?
Hi, Ben Kadek. So I came up to basically suggest that Victor write a standalone draft about the please solicit my client certificate extension, and that will give us a place to think about it, write down some security considerations, whatnot, and discuss whether it actually fits better in this document or in a standalone thing that would go to TLS or wherever. I also wanted to note that I know of some other non-SMTP cases where it would be useful. I think that the official MIT web server, like 15 years ago, if you spoke HTTPS to it, it would request a client certificate. And if you wanted public content, it had to be HTTP only. And that, of course, has changed since then. But the behavior regarding when to request client certificates on that particular web server is kind of interesting. And I think would definitely benefit from the ability to say, I want to get the authenticated functionality rather than the public functionality. And there's currently some hacks in place to approximate that. But I would like to see that as well. All right. Michael.
Michael Richardson. So that's an interesting thing, and I actually work with a number of, there's a couple of organizations that have client certificates everywhere, and it's actually really annoying because we have to split web servers and stuff like this, and it'd be really nice to actually have that. But the case I wanted to speak about actually was, and this is why I was thinking it did belong in this document, and it did belong in this working group, but Ben has now convinced me otherwise, was I think there's an awful lot of really crappy TLS implementations in microcontrollers that in IoT devices. And so well, the situation would really be that there's 100,000 of them out there. They're all going to crash if the the central point starts asking for certificates randomly. And so this actually is how you get them updated. And when they get updated, they may also get updated for 1.3 and a bunch of stuff, but that's not going to happen overnight. It's going to be incremental. And it's probably a sufficiently big upgrade that, this may actually involve more code storage and stuff like this. This may be forklift upgrades to get rid of them. So I think that's something to think about. And I also want to say from the earlier point was DTLS 1.3, I think, is much further away from being deployable than TLS 1.3, which is pretty much widely available.
Yeah.
So for those reasons, I really would like to have this please ask for my certificate. That would be really lovely. Yeah, please let's have another document. I would have just stuck it in the client auth document, not thinking that about the website use, but yeah, let's have another document and then let's argue over who gets to publish it.
Yep.
That's good.
It does
Okay, I
seem
think
that-
I'm persuaded. We probably should write that certificate soliciting extension.
It does seem like they should be independent and decoupled if they can be.
Yeah, decouple them in case other staff wants to use it too, right?
All right,
Okay,
so you're done?
yep, thank
All
you.
right, thank you very much. With that, we will move on to the use case presentations, who we're both hoping for plenty of time. We will start with Jacques.
Hello, hello.
Yep, go for it.
All right. So I'm Jacques Latour. I'm with Syrah. And I guess I'm here to talk about how we can leverage DNSSEC in digital identity. And I think there's a really good use case for DANCE, DANE, TLSA to work in this world. So I've been doing a lot of work here regionally on digital identity with DIAC and organizations like that focus on digital identity. They spend all of their time trying to figure out what trust registries are and how they
Can you
work in the
speak
grand
just a touch louder, Jacques, if you can?
louder. Where do I set that up?
But just talk louder. That's how you do it.
Talk louder. There you go. Okay, that's okay?
Yeah, we'll,
So-
we'll live. Just talk loud.
Or I can adjust the. Is this better?
No, that's worse.
So I don't know why this is not. I'll talk loud.
Worse.
All right.
That's good.
So digital identity world is all about trust registries. And the problem statement is, I think there's missing support in DNSSEC, well, it doesn't exist, for finding, identifying, and authenticating digital trust registries. So that's, next slide. That's what we're working on. So based in the digital identity world, there's an issuer of credential, verifiable credential. In our case, it's the IoT registry. We have wallets, holders of credential, IoT device, and an ASP is a verifier, and other stuff. So I'll start with the credential. Next slide. So we have an issuer of credential in digital identity world. So in this case, the IoT registry issues credential to a IoT device. So basically what that is, it's a digital certificate. It's got a SAN. The SAN has a fully qualified domain name here. That's DNSSEC with a unique identifier. And that's the ID, that's the identity of the IoT device. So you have a cert, a SAN, and it's signed by an issuer, which is, in this case, the IoT registry. So you have a certificate signed, and it's got two SANs, and it's, no, one SAN, and it's fully working. So next slide. So the issuer of the verifiable credential to that IoT device publishes in the DNS a TLSA record for that IoT device. So it's a hash of the cert that was issued, a public cert that was issued to the IoT device. And the SAN of that record matches the TLSA label here, and then you can verify that the IoT device is who they say they are. And that's the cool part with DANCE. This work, I love that framework. That's great. So good stuff there. So we got underscore device and then the UID, and that matches the certificate for that IoT device. Go back. So the IoT device, the cert is signed by IoT registry. And that's what we need to figure out. So we need a TLSA record for the public key of the signer available in the DNS. So you can verify that this cert matches the TLSA and the public key signing it to the signer matches with the TLSA record. So this we can do today. Next. So there's two ways to verify the certificate that's issued to the IoT device. There's the certificate itself it's signed by IoTregistry.ca. You can find the sub certificate in a trust store somewhere and make sure it's done properly. The digital identity world works at this level. And then in parallel with DNSSEC, TLSA, we can issue TLSA record for everything and do the same validation. So that works today. That's something we can do. Next. So I'm going somewhere. Don't worry. Next slide. So what you have is an issuer of, in this picture, oh, I see it. So you have an issuer, the yellow box, that issues credential and they sign with their yellow key. And then the wallet, the IoT device in this example, has a credential signed by the issuer, the IoT registry. And then when you present those credentials to the verifier, the application needs to verify that, you know what, in the digital identity world, it goes to a trust registry. It's how do I know those were issued by the proper issuer? The wallet says, am I allowed to give these credentials to that verifier? Do I trust that verifier? And the verifier says, do I trust this wallet? Do I trust this issuer? And there's a whole lot of discussion around trust registry focusing on that. So next slide. And the question is, it's always around the famous word, trust. How do you trust something in the digital identity world? And they have human layer trust, institutional trust, legal trust, technical trust. So I'm focusing on technical trust. So next slide. So I've been watching way too much Strange World thingy show on Netflix. So digital identity is on the top world. And I think DNSSEC can be in the underworld, the upside down world. And I think there's a way we can do DNSSEC, TLSA to support this environment. So human legal trust in the front, technical in the back with DNS. And the question is, if you have a verifier, how do you find the right trust registry that recorded those verifiable credentials? So next slide. So to do this, after a bunch of brainstorming, there's two things we need to do. So a trust registry is a thing that has an identity, and it needs to prove via TLSA record that an issuer or verifier has been registered in that ecosystem. So trust registries, it's all about that. It's recording the issuers, the verifiers, and other trust registries. So if the trust registry proves with a trust registry label that these things are part of it itself, so that would facilitate one part of the process. And the second part of the process is for a issuer of credential to have a new, yet another one, TR record, for example, to prove that they belong to a certain trust registry. So one or more trust registry. So next slide. So if we look in the case of the identity, the IoT registry issuer registration, if we look at it in that context, it builds a chain of trust between a trust registry and a issuer of credential. So we have IoTregistry.ca. They have a TLSA record for the root cert that they use with the public key. And they have a TR record saying, you know what, IoT registry is registered in trustregistry.ca. So trustregistry.ca is the entity that registered IoT registry based on its governance model and its rules and all that. And then trustregistry.ca publishes a TLSA record with a trust registry label to say, you know what, IoTregistry.ca._trust registry is registered inside the trust registry for Canada with a TLSA with a hash of its public key. So it's kind of like a DS and DNS key thing, and it creates a chain of trust. So if a credential is, if somebody looks at a credential, they can work out which trust registry you should go look at to find that issuer and get all the keys to make sure that they're signed properly and all that. So the ability to do this in the digital world does not exist. They haven't figured out how to do that part. So I think if we do something like this, it facilitates the process. So next slide. And then the other one is, how do you work this all the way down to a global chain of trust for trust registries? And I think that's kind of, this answers the question for the people here in Canada, for example, in the digital identity. If they get a credential issued by another country, how do they go back to that country to figure out it exists? So if you have a chain of trust like this, where the IoTregistry.ca is registered in the trustregistry.ca entity, and the trustregistry.ca is part of a IANA trust registry, and the IANA trust registry has a trust anchor in the root zone, then with the NSSEC, you can build a chain of trust all the way down to make sure that, you know what, this trust registry, there's a chain all the way down to, then it's authentic information. Is it legit? Totally different issue. We can have malicious DNS record signed with the NSSEC. We don't care. Well, we care, but technically we don't. So this is about building trust registries being part of other trust registries and having a chain of trust from IANA. And I think if we do something like this, it would enable it. So there's a whole lot of discussion in the digital identity world in anchoring all the digital identity documents inside blockchain. And my hope here is that we could use this to anchor digital identity instead of blockchain and show that, you know what, this can be trusted from IANA up. It's kind of delegated, decentralized model. So next slide. Yeah, next slide. So I think, you know, at a high level, there's a good story. Alex started to work on a draft for DID DNS 03 to link DIDs to DNS. So, you know, I just focus on the DNS part here, but there's more to this story than this. So we have a repo in GitLab with Dance, with this presentation and other stuff. But I think in the end, if we had something like this, it would be good value for the digital identity world with trust over IP, with W3C to anchor with confidence the DNS inside the digital identity world. And that is the deck.
All right, thanks, Jacques. Certainly interesting case with lots of new things. In the interest of time to keep on track, so we have more time for another presentation, I'm asking clarifying questions only.
Yeah.
If you have, you know, should we do this or should we not, that it is a future charter item and should go to the mailing list. And I would love to see discussion on it, don't get me wrong, but not today on the mic line. Go ahead.
Clarifying question. Why did you put IANA in there other than the fact that other people know it? Could that be some other organization that is the collector of trust organizations? Could it be something in the UN, something else, or does it need to be IANA?
No, it can be anything. You're right. But IANA, we know what IANA does, right? So that's why I put it there. But it could be somebody else.
Victor?
Just quick, I'm a very simple person. I don't understand this at all. Could you publish some simple use cases, requirements, documents? I'm seeing an architecture that I just don't understand at all. So it would be helpful to explain this to people who are not too clever like me.
Yes, exactly. It took me a while to figure this stuff out. Agreed.
I think that'll come. This is the high-level early introduction. John?
I'm an even simpler person than Victor. Why do we need a new RR type for this?
It's to, so the clarification is, if you have an issuer, if somebody issues credentials, to show which trust registries they belong to. So let's say you have a university that issues graduation certificate or diplomas. Then in Canada, you would have a trust registry with all the universities in Canada that are registered in there. And then when you receive these credentials from these university, you can check in that trust registry to make sure they're part of that group. That's what
I do encourage everybody to read the slides, because I got it only after seeing the slides multiple times while doing review that it made sense. So it is a complex use case, but it's an interesting one. So do read his slides multiple times and it will help.
I'll try to make
All right,
it
Jacques.
clear. Thank you.
All right, thanks very much, Jacques. All right, so we'll turn to Bob now he's going to talk about fun with drones.
Okay, thank you very much. And this will be looking at identifier in a different light than we just had, and how I'm looking at leveraging DANCE for unmanned aircraft communications. Next slide. And fortunately, I'm dealing here with a green field. Most communications today is line of sight, often with no AP, and this is changing. It will be constrained capacity that we have to deal with. There are two basic types of communication: command and control, typically called just C2, between the unmanned aircraft and the ground control station. The other one is network remote ID, which is the telemetry from the unmanned aircraft to the unmanned traffic management system. Next. Even autonomous operations need communications. The C2 updates both ways, but less traffic than non-autonomous operations. But telemetry is we always must do telemetry. And if autonomous, it must be from the unmanned aircraft, not from the ground control station. Because in non-autonomous operations, the ground control station gets telemetry anyway as part of the C2 and may do the forwarding to the UTM. Many of you may be aware of the manned aircraft ADS-B. This is not an option. We've been told in the regulations that ADS-B will not be used for unmanned aircraft. And if you have any questions, we do have some people here who can answer that directly, but you can take my word for it. And finally, there is a lot of talk that future of UTM rerouting directives direct to the UA. So how the UTM will tell the UA, you need to move here to avoid this situation. And that will go, particularly in autonomous operations, may go directly to the UA to make a timely move for whatever reason. Next. So now I need to secure the UA communication. There's likely two choices, and that's ESP and DTLS. DTLS is a likely choice for most network remote ID because it's to a fixed known network remote ID service provider. But when the UA is on multiple interfaces, there's a known problem with current DTLS code that it can't handle changes on which interface is coming, but that should be fixable. That sounds like just an implementation in the code problem, but it has been brought to my attention trying to do this. When the ground control station is mobile, ESP is more likely to be the mobile IKE or HIP for the command and control. An example of that is UPS is proposing that the UPS trucks will be a ground control system with the UA being launched from the truck, and it's making delivery while the operator is going to the next place, and so it potentially move around the network. And so ESP in beat mode is naturally multi-homed, and will work well in this either keyed either way. And all this is in my draft MOSFET Secure NRID C2. This has not been adopted by the DRIP. I left out DRIP in there, left that out, by the DRIP work group, because they want us to first finish the broadcast remote ID before we tackle the network remote ID. But it is current work for the group. Next.
Do you want to take Martin's comment now? Or
Martin?
Yeah, I just wanted to ask, I can think of a third choice. Quick does some of the multi-homing things and has all of the same properties as DTLS, but provides some superior, perhaps, application layer semantics, like streams, for instance.
It is a potential. I've not heard discussed. There is a directive from ICAO for manned aircraft. The manned aircraft will be DTLS. Okay. And so kind of figured that, but you're right. Quick is potentially another option, which I've not delved into yet.
Okay. Yeah.
TBD.
These things are not made in a vacuum, so I'm kind of surprised that you're just accepting a mandate on that one, but I guess it's maybe not your decision to make. Yeah.
Now, the UA identities are defined in draft IETF DRIP RID, which is finishing up its review and could be done pretty soon. The registry's draft needs a lot of work still, as came out from the hackathon this past weekend. The DRIP entity tag, the DET, is a hierarchical host identity tag, which is an update on RC 7401. DETs are session IDs, which may exist for the life of the UA or for only a 30-minute operation. Technically, we call them operations, not flights. And EDDSA 25519 is used for the raw public key. That's because it gives us some nice size characteristics to work with. So define DNS FQDNs for all DRIP-enabled UA. It's very easy because of the structure there to set up that the DET resolves to this particular FQDN. And if the DET is not in DNS, the DET was revoked. So there's no revocation process in here other than if you can't find it, it was revoked. And if you have authorization, you can ask the registry, why was it revoked? And it may tell you if you have rights. So DET's stored in DNS either or both in the HIP or TLSA resource record, depending on which protocol you're using to do it. And these are all the raw public keys, which is basically, it's just how they're wrapped differently from the two. Otherwise, it's the exact same content. Next. So DETs and DNS trusts may be established by DNSSEC. But will this be possible for zones run by the HIT domain authorities, the HDA, with hundreds of new DETs per hour be able to sign the zone? To be determined. But no, if this is a registry which is supporting a delivery service, which is requesting a bunch of session IDs for each delivery operation, there are going to be millions of these created and aged out quite rapidly, and will DNSSEC be able to deal with that? Unfortunately, now I say attestation here, we have since learned that in RAT's determination it should be evidence. So in my slides where I say attestation, think evidence in the terms of RATs. So the registration evidence insert resource records via private OID. And that's just how you can put, private OID allows you to put any object you want in a CERT resource record. See the registry's draft and how I'm doing that. The interesting thing is provides proof of registration and thus trust in the DET without having DNSSEC. So if you receive, if you're able to pull out or actually receive it in the broadcast message, this registration evidence, you know that this DET has been registered. You have the proof of that without having to have a signed zone, because you have the independent tree of the signing of the registries and how they are authorized. Next. So that's all the background. And now I'm up to UA and dance when using DTLS. We could send an IRC 2750 raw public key of the high, but then how do we link it back to the DET? It's better to use dance with the known FQDN we derive from the DET to retrieve everything from DNS. The pieces just fit. But server side may need some special help on the evidence for trust, if it's not the DNSSEC evidence for trust. Next. But these were a limited number of servers. These are the servers run by the network remote ID service providers. So we're not talking about a large community. And if DRIP is widely adopted, this could mean millions of UAs in the coming years feeding telemetry into UTM, even via the ground control station. And note that C2 will tend to use pre-stored UA identity for DTLS authentication because you have this natural, you purchase your UA with your ground control system or you install the software on your smartphone. So that's like a closed environment there. It's more involved, but can work for other proposed solutions from other STOs. That my DRIP proposal for remote ID is not the only extant one. There are others. It gets a little bit more complicated for what they're doing, though it is doable for them as well. Next. And that completes my slides. And our intent here that I'm looking that DTLS may be very important for a number of reasons, and that then using dance for how the identities, how that I just pass the FQDN in the handshake, don't have to pass all the rest of it. The server can look it up and it will just work well. And it could end up being a lot of it. Paul.
Hi, Paul speaking as just an individual. I just wanted to remind you that we have ways of storing chains of DNS records, the query chain, and you can use them to offline synchronize your client server state if you pull that from the DNS. So if you're offline, you can keep your own link to the root and refresh it regularly when you're online. And then you have like a pretty up-to-date valid path you can send to the other side of the TLS connection. Yeah. And you can, so these DNS query chains, you can embed in TLS because you have also an extension for that.
Before you take off, your UA has some good bandwidth connection, maybe through the ground control system, to do that pre-setup for takeoff. But then I'm dealing with for like cargo delivery, which is then going from one UTM space to another UTM space. How do we do the handoff? Particularly if the operation that was filed, you have to change it because of weather or whatever. And so then that may get exciting. I don't have an answer yet how to do that one. That's still TBD. And looking at my colleague on the FAA side, and he's shaking his head because he has the same class of problem on much bigger pieces of hardware than I do.
So one thing that has always been interesting to me with things like dance and Dane is, which I think matters to you more than anybody else, is bandwidth savings. So have you done any measurements to determine, by using Dane and dance that you can actually reduce the certificate
I am
sending?
doing byte counting. I know I'm looking really hard at Chic for how we're going to be compressing this, and why I want Chic end to end, not just Chic on the wires, because some of these, the avionics, that you may have an Ethernet network on the larger UAs, and so the avionics are Ethernet connected. They don't know the characteristics of wireless, and so how do we do that? So I'm literally counting bytes, and I haven't gotten into those. I've been concentrating more on the headers, but that's the next step that I need to do, and I'll be in the next 3 months be working through that. Yes.
It would be neat to see a comparison of with and without Dane and dance.
Right. Yeah. So that all has to, that is all on my list of things to do.
Does some of this apply to? I know the early discussions in DRIP had to do with sending data over Bluetooth, which is a pain in the neck, or is that?
That
totally
is
different?
pretty much done.
Okay.
That is the DRIP auth draft,
Right.
which is in work group last call. And that is how working within, we only have 200 bytes to work with. How do we do the proofs and everything in 200 bytes? And I've done it.
All right, Victor?
Just exactly in 200 bytes.
I applaud the use of raw public keys. It's a cool idea. I haven't seen any TLS stacks that actually support this. Are these going to be sort of ground up, not the usual TLS stacks we're used to seeing in sort of the open source world? Do they exist?
Well, that's, yeah, and also that's why looking to dance, the dance FQDN, so that's sending it back to only the FQDN, not the raw public key in terms of what is passed. You people know more about this than I do. I may be stepping my foot in something that I don't know I stepped into.
Sorry, Paul, I know that Hannes actually has raw public keys working in various of the stacks that he worked on.
Thank you.
Ben?
Likewise, there's also code for OpenSSL to do raw public key, and I thought it had not been merged yet, but I'm not seeing an open PR. I can send the pointer to Victor offline, since Victor is in position.
Victor,
Okay,
Victor's
excellent.
not
Thank you.
nodding his head, so.
So we still have a row to hoe here, but this is the direction that we're going.
All right. Any last questions?
Thank you for your time.
Thank you. So I'll remind everybody that, you know, some of these use cases do require additional drafts and protocols and stuff. And we knew when we started dance that once we got over the base, you know, a couple of documents as well as how it was all going to fit together. If you remember in the very first, you know, Danish BOF, before we were dancing about Danishes, you know, there was a lot of questions about how all these things were going to fit together. And you can see some of these use cases are getting, you know, pretty complex and out there, but that's how it started from the beginning. So thank you everybody for coming. It looks like we're close to getting the, you know, the first two real core pieces of protocol documents done. That would be awesome. And I think it'd be about a year. I think that may be almost a record for a DNS, for a working group, certainly for a DNS working group. So thank you, everybody. That concludes today's dance session. You may dance freely among yourselves.